Morning, guys. We did ionic bonding the other day. So I just want to start by going through the homework. So this was the question: how do calcium and oxygen react? I had done one of these between, I think it was sodium and chlorine. So yeah, just wanted to see if you could do it. I just snipped the periodic table in here just so I didn't have to keep going back. Okay, so we will start with calcium. And calcium is here in green in group 2 with 20 electrons. Okay, so first orbital or shell will contain 2 electrons. Second orbital or shell contains 8. So 2 and 8 means I've done 10 now. So 8 in the next one. Oh, sorry. 8 in the next one. What should I say? 10 and 8, so that's 18. And God only knows what this will look like. No. Hang on. I'll try again. Slightly better. And we have 2. So calcium is going to want to give away these 2 electrons. E minus is a symbol for electrons. I don't know if I said that to you the other day. Yeah, it's much more likely that they're going to give away 2 than they're going to get 6. So they're not going to get 6. So they're going to want to give those away. So now let's have a look at oxygen. I think oxygen's a bit smaller, isn't it? Yeah, there it is there. So oxygen is 8 electrons. Move this over a little bit more. Sorry, I shouldn't get it out of my way a bit. Okay, so oxygen has 8 electrons. So oxygen, 8. So the first orbital or shell contains 2. And then the next one, so 2, 3, 4, 5, 6, 7, 8. Okay, so oxygen needs 2 electrons to make a full outer shell. Okay, just so we can see that. Okay, so they always pair up nicely like this when we're doing ionic bonding, that you have one element where it needs to give away a certain amount of electrons and then another element where it needs to get those electrons, and they pair up nicely. So calcium is going to give away that electron over to here and that electron over to here. Okay, so calcium has given electrons away, so it's given away negative charge, so now it's positively charged, and it's given away 2. So it's calcium 2+. It's a positively charged ion. Oxygen has taken on 2 extra electrons, so it's taken 2 extra negative charges. So now it's negatively charged, so it's oxygen, and then because it's taken 2, it's taken 2 electrons, so 2 minus. So calcium has become Ca2+, and oxygen has become Ca2-. Alright, so that's the homework. We'll keep going. Friday the 12th of March. Right, so okay, so there's our ionic bonding where the electrons are given away, okay? Today we're going to look at covalent bonding. Okay, so covalent bonding is formed when pairs of electrons are shared between two atoms, okay? Now hang on, I just want to... Sorry, I always forget that I have to scroll to the same place on the iPad. Just assume they should link up. Okay, so a covalent bond is formed when electrons are shared. When we're doing the diagrams now in a minute, you will find that both atoms need electrons. So you know the way when I did the ionic bond there for homework, I was able to say that calcium wanted to give away electrons and oxygen needed electrons. In covalent bonding, it tends to be the case that both need the electrons, okay? And that's how you know it ends up being a share, because nobody's willing to give them away. Like one atom is like, well, I need two, and the other atom is like, well, actually, I also need a few. You know, they're like, oh, well, look, let's just share. Okay, so that's generally how we end up. Oh, I have this doubled up for some reason. Hang on, I'm just going to... Sorry, no, it's just the same paragraph twice. So, right, let me show you. I found this, and this is kind of nice. Okay, so hydrogen. So hydrogen is a little bit of a weird one because hydrogen, it only has the first shell. So for hydrogen, a full outer shell is actually 2 because it only has that first shell. Okay, so here we have a hydrogen on the left with 1 electron, so it needs 1. And then on the right, we have 1 electron, so that needs 1. So both of these hydrogens are in need of a second electron in order to make their outer shells full. So they decide to share. So now both of the hydrogens have a full outer shell. So atoms share a pair of electrons to form a single covalent bond, and a hydrogen molecule is formed. Okay, if we were to write the chemical symbol for that, it would be H2. Yeah? I'm actually just going to put this into this just because it's kind of nice. Yeah, we'll stick it out to the side. Okay, so both of those hydrogens were in need of an extra electron. Again, they were both in need. If you look even here, I can highlight this now. In both cases, they needed an electron, so they decided to share. They now both have a full outer shell. Okay, again, I know it's only 2, but because they only have the first shell, that is full. And then the molecular formula for that is H2. So it's 2 H's. Yeah? Okay. Okay. Right. Oh, what am I doing? Okay. So here's another one. Okay, so we have hydrogen chloride. Okay. So we'll do the same thing. I'll bring it over here. So chlorine is in group 7. And so it has 7 electrons in its outer shell. So it needs 1 more electron to complete the outer shell. Hydrogen has 1 electron. It needs 1 more to complete its outer shell. Okay, so again, they are both in need. So what do? They share. So the hydrogen now has this one, see the one I'm pointing at, and this one, so it has 2. And the chlorine has 1, 2, 3, 4, 5, 6, 7, 8. So they're sharing these 2 electrons here. Okay, and the molecular formula for that one is a hydrogen and a chlorine. So HCl. Okay? Okay, here's another one, methane. Oh, actually, I'll go on one more. Sorry. Oh. Okay, so each hydrogen needs 1 electron. So each one needs 1, okay? So we need, this one needs 1, this one needs 1. Yeah, each one individually needs 1 to make up the outer shell, okay? And over here then on the far side we have carbon. Carbon is in group 4 of the periodic table, so it needs 4 electrons to complete its outer shell. Okay, so they work together. So each of these hydrogens are going to come over and form covalent bonds with the carbon. So now you have this hydrogen has a full outer shell of 2 electrons. This hydrogen has a full outer shell of 2 electrons. This hydrogen has a full outer shell, and so does this one. And then the carbon also has a full outer shell of 1, 2, 3, 4, 5, 6, 7, 8. One more. So carbon shares all 4 of its electrons to form 4 different covalent bonds. Now, what does the molecular formula look like for this one? You have a carbon and then 4 hydrogens. So CH4. Yeah, this one doesn't work properly, so I'm just going to fly to this one. Water, okay? That's actually one they have in your book. So this is the last one I'll do now. Hopefully you're getting the idea. So again, we have atoms in need. So each hydrogen needs an electron, and the oxygen actually needs 2 electrons. It's too short, okay? Everyone is in need again. So what are they going to do? They are going to share. So now the hydrogens have their full outer shells, and the oxygen has a full outer shell. Okay, so the oxygen has 2 covalent bonds, and what's the molecular formula? H2O. So 2 hydrogens with 1 oxygen. Yeah? Don't know where it goes after that. Yeah, all of what we've done. Okay, so I have all those nice covalent bonds there for you so you can see them. There's 4 of them done there. And they've done some of these in your book as well. There's water. Oh, they've done methane as well, which we've done. Okay, so I'm going to get you to do some of these for homework. Yeah, I'll come back to it. Okay, this is important. So I was just doing molecular formulas, and you need to be able to do molecular formulas, okay? But they're not as easy as maybe they look. So in these pictures that I gave you up here, we started with 2 hydrogens, we ended up with H2. We started with a chlorine and a hydrogen, so we had HCl. It's quite easy once you have the pictures. But when you're asked them like this, what is the formula for potassium oxide? It's like, what? I have no idea. Okay, so it's a little bit challenging. So I have a little method to do it here. But first I need to tell you what valency is. I'm just going to try and highlight this. Does that work? Yeah. Okay. So valency is the amount of electrons an atom is willing to lose, gain, or share in order to get a full outer shell. Okay? Now, this is how valency works. Okay? When you go across the periodic table, valency is 1, 2, 3, 4, 3, 2, 1. Right? Let me try and explain if I can find the periodic table. Here it is. Okay. So, sorry, I did it again. Forgot to do the iPad. Here it is. So what did I say that was? I said it was 1, 2, can you see me down at the bottom? 3, 4, 3, 2, 1. Okay, that's the valency. So what that means is that if you're in group 1, you're willing to lose 1 electron. Your valency is 1. It's your, I think they call it combining power. So that's what you're willing to give up. Because if you give up any more than 1, then you're eating into your full shell, which you don't want to do. So that 1 spare electron, if you're a group 1 element, you just want that one gone. Okay? If you're a group 2 element, like calcium, we did this one for homework, calcium wants to give up those 2 electrons. Okay? No more, no less. Because less and you're still pretty reactive because you've got 1 extra electron. And if you give more, you're eating into your full shell, so you won't be very stable. Okay? Third group, 3 electrons in the outer shell, willing to give away that 3 electrons. Okay? Now, group 4 is sort of, they sort of describe it as like a variable group. So it will either accept 4 extra electrons, or it will give away 4 electrons, or it will share 4 electrons like we saw with methane. Okay? So these want to give away 1 or share 1. These want to give away 2. These want to give away 3. These want to either give away 4, get 4, or share 4. Into group 7. Okay, in group 7, they're never going to get rid of 7. So now so what do we have? Sorry now, what group am I in? Sorry, I'm in group 5. So these atoms have 5 electrons in their outer shell. They are never going to get rid of 5. So what they're going to do is attempt to gain 3. Okay, so that's why this is a 3. In group 6, there's 6 electrons in the outer shell. They're not going to be able to get rid of 6. That's too many. So what they will do is look to get an extra 2. They'll either look to take them from one of these elements over here in an ionic bond, or they'll look to share them. But they need an extra 2. And then in group 7, there's 7 electrons in the outer shell, so they gain an extra 1. Okay, so that's how the valency works. So if you're in group 1, you have a valency of 1, you want to get rid of that 1 electron. If you are in group 2, you have a valency of 2 because you want to get rid of your 2 electrons. If you're in group 3, you have a valency of 3 because you want to get rid of your 3 electrons. If you're in group 4, you have a variable valency. So basically you either want to get rid of 4 or you want to get 4. It's much of a muchness. Once you get over the hump, over halfway, these have 5 electrons in their outer shell. So rather than getting rid of 5, they're going to attempt to get an extra 3. So that their valency is 3. Group 6, they already have 6, they just need 2, so their valency is 2. And group 7, they have 7, they only require 1, so their valency is 1. Okay? So that's how valency works. Here it is. So valency is the amount of electrons an atom is willing to lose, gain, or share in order to get a full outer shell. Okay? So there's a couple of steps here. Step 1, write down the symbols of both the elements involved. Step 2, beneath each symbol, write its valency. So that's where this is going to be. You have to write down its valency. Okay? Swap the valencies over. And if the valencies can be simplified, simplify them. All right? So let's go through this. So potassium oxide, and that's going to be, that's going to be, well, obviously this is potassium, and oxide is oxygen. Okay, so the symbol for potassium is K, and the symbol for oxygen is O. Okay, so K, I think I'm going to need to get, sorry, I'm going to need to bring this down because it's a pain going up and down. So I'll just snip it again. Just make sure I have the valencies in. Okay, so potassium K, you can see it here. It's in group 1. It has a valency of 1. So there's the valency of 1. Oxygen O is over here. It's in group 6. So that means it has a valency of 2. It wants 2 extra electrons. Okay? Sorry. Okay? So this potassium has a valency of 1 because it's in group 1. Oxygen has a valency of 2 because it's in group 6, so it wants to give away 2 electrons. Swap the numbers over, so literally the 2 comes over here, so this is a 2, and the 1 goes over there, so you just swap them. Now, if they can be simplified, simplify them. So for example, if this was an 8 and this was a 4, I would divide them both by 4. If this was a 10 and this was a 2, I would divide them both by 2. Okay, so if they're simplifiable, just like fractions, then simplify them. Okay, these aren't, so we didn't actually have to do this step. Okay, and then you have it. So it's 2 potassiums, 1 oxygen. And the molecular formula, K2O. 2 potassiums, 1 oxygen. Okay? So, I'm going to try this one. I'm just going to move it over here so we can do it ourselves. Okay. So, aluminium oxide. So, aluminium is obviously aluminium. And oxide, yeah, same again, it's oxygen. Okay, so the symbol for aluminium is Al and the symbol for oxygen is O. And I'm just going to put a line down the center of those. Right. So where's aluminium? There it is there. See it there? So aluminium's in group 3, which means it has a valency of 3. Okay, so I'm going to put down valency of 3. And then oxygen. Oxygen is here in group 6, so that means it has a valency of 2. It wants 2 extra electrons. 2. Okay? Then we do the bit, which doesn't require any real skill, where you just swap them over. Okay, so I swap the numbers over. The next step is I divide if they do have a common factor. Okay, so they don't. 2 and 3 can only be divided by 1, which won't change it. So I skip the divide step. Yeah? And then I have my formula. So it's 2 aluminiums and 3 oxygens. So the formula is Al2O3. Yeah? Now, I want to draw this one just so we have an idea. So what did I say aluminium was? So it's up here. See it with 13? So let's draw aluminium. So aluminium has 13. Okay, so okay, so there's 1, 2, yeah, and then the next one gives me 3, 4, 5, 6, 7, 8, 9, 10. And then the next one, I have 1, 2, 3. Yeah? Now, according to my molecular formula, I need 2 of them. Okay, so I'm going to draw another one. Exactly the same. Actually, I wonder, can I just copy it rather than drawing the whole thing again? Sorry, hang on 1 second there. Okay. Excellent. That saved me some time. Okay, so there's my 2 aluminiums. And then apparently I need 3 oxygens. And we're just going to see if this works out. Okay, so my oxygens, I'll do them in blue. I've looked at oxygen with 10 times. Is it 8? Yeah. So oxygen has 8. So we do our circle. So there's 1, 2, and then 3, 4, 5, 6, 7, 8. Sorry, you're missing a couple of them. Yeah? And I need 3 of them, so I'm just gonna... Awesome. And then we'll go again. Okay. So that's what the formula says. The formula, according to my little method, says that I need 2 aluminiums and 3 oxygens, and they should be able to do covalent bonding and share. Yeah? Now, I'm not going to be able to do the animation and move the way obviously the PowerPoint could, but if you can hopefully just imagine this, okay? So if you look down here, this aluminium can come in here. Yeah, I can do a share there. Okay, and then likewise I can do a share here. Yeah? So now we have that shell full. I have 2 I need to get here, and then I have 2 I need to get here. Okay, watch. This one can share there. This one here can share there. This one here can do a share there, and then this one here can share there. So it all works out, okay? Drawn like proper molecular diagram. There it is there. See? Here's your 2 aluminiums and your 3 oxygens in red. So your silver are your aluminiums, and then your reds are your oxygens. Okay? So there's no need to necessarily draw it. I was just drawing it to show you that the method works, that when you generate the formula, it actually works out. So there's one more here, carbon sulfide. So carbon is carbon. And sulfide comes from sulfur. Okay, so carbon, there's carbon there. So that's in the 4th group. Remember that had the valency of 4, was kind of stuck in the middle. So that's where that 4 is coming from. Sulfur, there it is there, look, S. So that's in group 6, which means it has a valency of 2 because it wants to get rid of or it wants to get an extra 2 electrons. So that's where the 2 comes from. Swap them over. Now here, look, here we can divide. So both of those numbers will divide by 2. When you divide 2 by 2, you get 1, and when you divide 4 by 2, you get 2. So now we know it is 1 carbon and 2 sulfurs. So you end up with the formula CS2. Yeah? Okay, so I'm going to get you to do these 2 little boxes here for homework. And just to be aware, pretty sure it's what they're getting at. The combining power here, that's another way of saying valency. Okay, so these 2 questions are going to be for homework. I might see, I definitely did one with the 3rd years recently, generating the molecular formula. So there might be a 3rd question there by the time you see it. And it'll just be basically practicing getting the chemical formula using the little method down below. So if I can find the question I'm talking about, because I only did it last week with the 3rd years, I'll put it in. Okay, so whatever's there, it's definitely 2 questions, and it might be 3. All right, well done, guys. I'll chat to you Tuesday.